Today is our last new lesson of the semester. We're going to talk about equations that have algebraic fractions in them. Friday, you have Quest 5, Group Quest. I've talked about it the last couple classes. Your group can be as large as you want. You can use the boards. You can use your notes. You can't use me or another professor from the math studio, but any of your classmates. Yes? You can refer to anything. Anything in your notes. Yeah. Yep. Yep, you can have your notes open. Yeah. Okay. So hopefully that will give everyone a little Quest average boost. And then Monday we're going to review for the final exam. You have practice problems, a practice problems packet. I'll make a few extra copies for Monday. Practice problems for Math 096. I gave it to you on the first day of class. There's also some practice things that you can do in my math lab. And then our final is Friday the 22nd. So there's going to be quite a delay between our review class and the final. Yeah, it's at 10:30. No class on Wednesday. You might, if you're taking other classes, you might have finals on Wednesday, but nothing for this class. No, that's just because Ian and I used the same file. Yeah. Yeah. If you have a conflict with the Friday time, just talk to me personally. We can figure something else out. Okay. Talk to me outside of class if you have a conflict. Okay, so let's look at. No, you can't do that. No. If you have a conflict, we can work something out outside of. Talk to me privately. Okay, so in this lesson, we're going to solve equations that involve algebraic fractions. We're going to continue to use the least common denominator, but it's going to play a little bit of a different role today. All right, when you're solving equations, once you get all the fractions to have a common denominator, by completing them with what's missing, just like we did when we were adding and subtracting them. Okay, so you get all the fractions to have the same denominator, then multiply both sides of the equation by the common denominator. The effect will be that it will all the denominators will cancel. And then you'll have a fraction-free equation to solve. Do a little happy dance because you got rid of all the fractions. Okay. Absolutely mandatory to go back and check your answers by substituting them back into the equation, because sometimes you'll get fake answers, right? They're called extraneous solutions. And you'll solve and you'll have two numbers that are supposed to be solutions. You'll plug them in, and sometimes one of them is not actually a solution, and you have to throw it away. All right, so let's do one to practice together. So 1 over x equals 8 over 6x plus 3. So my first step is factor all the denominators. I want to get a common denominator for those two fractions. So 1 over x can't be factored any further. So I'm just going to write it like that. And then I have 8 over, can I factor 6x plus 3? Yes, what is the GCF of 6x and 3? 3. So I'm going to have 3 times x plus 2.
2x.
Oh, sorry. Oh my goodness, what am I doing? That was completely wrong. Okay, 3 times 2x plus 1. Better. Okay, so now I want to complete all the denominators. I'm going to try to build an LCD. Anything that's missing in one fraction has to be added, right? Anything that's in one of the fractions that's not in the other needs to be added. Okay, so I'm going to do this in the same line, but with a different color so you can tell that it's a different step. Okay. So in this first fraction, anything show up in the second fraction's denominator that's not in the first? Everything, yeah. So this has to get multiplied by 3 over 3 and 2x plus 1 and 2x plus 1. Get everything. And then what's missing from the second fraction's denominator that's in the first? x. So I'm going to multiply by x on the top and the bottom. Okay, now we did step 1, factored everything. We completed all the denominators. Step 3 is to multiply both sides of the equation by the LCD. And the LCD is the common denominator we just built. The denominator of both fractions is now x times 3 times 2x plus 1. They have the same denominator, it's the LCD. If you multiply both sides of this equation by the LCD, so I'm going to rewrite the equation down here. So I have 1 times 3 times 2x plus 1 over 3x times 2x plus 1 equals 8x over 3x times 2x plus 1. I'm going to multiply both sides of the equation by the common denominator. Multiply the left side by 3x times 2x plus 1. Multiply the right side by 3x times 2x plus 1. So that's allowed. I can do anything I want as long as you do it to both sides of the equation, right? So I'm multiplying both sides of the equation by the same thing. So this is completely legal. The reason I'm doing it is because it has the effect of canceling all the denominators, right? This is because these guys are actually like over 1, and then I get to cancel that with that and that with that. All the denominators go away. And now I just have a really basic equation that you could have solved before this semester even started. Now I need to solve 1 times 3 times 2x plus 1. Nope, I'm looking at the numerator. Yep. Equals 8x. 1 times 3 is just 3, right? I don't really need that 1 there. I can distribute my 3, and I get 6x plus 3 equals 8x. Subtract 6x from both sides, and you get 3 equals 2x. And then divide both sides by 2, and you get x equals 3 halves. 1.5 and 3 halves are equally simple. You can do either way. So what do you think? Okay? All right, so we should always go back and check with the original equation, right? So I have 1 over x equals 8 over 6x plus 3. I'm going to write this under here. 1 over x equals 8 over 6x plus 3. I'm going to plug in 3 halves everywhere I see an x and make sure this is true. 1 over 3 halves, does that equal 8 over 6 times 3 halves plus 3? What is 1 divided by 3 halves? Nope, because 3 halves is 1.5. What's 1 over 1.5? 1 over 3 halves. 2/3. Yeah. 1 over always has the effect of making a reciprocal. 1 over 3 halves is 2/3. Okay, does that equal 6 times 3 halves? What is that? 6 times 1.5. 12/3, which is? And no, it's not 12/3. Sorry. It's 9. You multiplied, you flipped the 3 halves in your head. 6 times 3 is 18. 1 times 2 is 2. It's 18 halves, which is 9. 8 over 9 plus 3. 9 plus 3 is 12. Does 2/3 equal 8/12? Yes. So 3 halves is actually a solution to this problem. All right, let's do one more together. This one's a little bit harder just because there's 3 fractions now. But we've dealt with finding common denominators of 3 fractions before, so we can do it again. So first thing, factor all your denominators. So 2, I'm going to write that as 2 over 1. And I'm going to make my nice big fraction bars so that I can use that space to build the common denominator. X minus 2, does that factor any further? No. So I've got plus 4 over x minus 2. And that should equal 8 over, let's steal a little space from there, x squared minus 2x. Does that factor? Yeah, it's got a GCF of x. So I'm left with x minus 2. So again, I'm going to build my LCD. Any fraction that is missing something another fraction has, we need to add it in. Okay. So my first fraction, are there any factors in the denominators of the second two fractions that the first one doesn't have? Yeah. X and x minus 2 are missing. So I'm going to multiply this one by x over x and by x minus 2 over x minus 2. So again, this is a second step. I'm writing it in the same line so that you can see that it's another step. The other color shows that it's a second step. Okay, 4 over x minus 2. Is there anything from this denominator, from the first denominator, that's not in this one? Well, now that I've changed it, yeah, there's an x. The 1, yeah, but that doesn't matter because multiplying by 1 won't change anything. So what I just need is an x times x over x. Now this last denominator, does it need anything? No, all of my three denominators are the same now, x times x minus 2. So I can give that space back. Okay, they all have the same denominator. So I'm just going to rewrite the whole thing, and I'm going to make it a little smaller. So I have 2x times x minus 2 over x times x minus 2 plus 4x over x times x minus 2 equals 8 over x times x minus 2. So I didn't really do anything in this step except maybe change the order of some of the multiplication. Yeah. Mm-hmm. X squared minus 2x, is there? Nope. No, it wouldn't work. No. Okay, so my next step is to multiply both sides of the equation. Now that you have all the same denominator, what is it? Nothing? You sure? Okay. All right, so now that I have all the same denominator, the way I get rid of the denominators is multiply both sides of the equation by the common denominator. And then all your denominators will cancel. That's the beauty. Cancel, 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 cancel. All the denominators go away. And I'm just left with 2x times x minus 2 plus 4x equals 8. Distribute the 2x, and we get 2x squared minus 4x plus 4x equals 8. Minus 4x and plus 4x cancels out. So 2x squared equals 8. How do I finish solving that? I can divide by 2, so I get x squared equals 4. Square root both sides. And I get x equals 2 or negative 2 plus or minus 2. No. Oh, because it's the square root, yeah. Okay, so there's my answer. 100% mandatory to go back and check that both of those numbers are actually solutions. Okay, so plus or minus 2. So I'm going to look at the negative 2 first. That's why I have 2 spots here for checking. I'm going to do x equals -2 first. I'm just going to replace all the x's in the very original equation with a -2. So I have 2 plus 4 over -2 minus 2. Does that equal 8 over -2 squared minus 2 times -2? All right, so I have 2 plus. What's -2 minus -2? Sorry, -2 minus 2 is -4. So this is 4 over -4. Does that equal 8 over -2 squared is 4. -2 times -2, +4. All right, what is 2? 4 over -4 is -1, right? 2 plus -1 is 1. 8 over 4 plus 4, is that 1? Yeah. I actually have a solution. X equals -2 is, in fact, a solution. Yeah. Right here. -2 minus 2. So if you start with -2, subtracting 2 would... Oh, okay. Yeah, in the next one, there's a typo in your packet. All the math is done correctly, but we're supposed to be checking x equals +2, not -2. We already did -2. All right, so again, in the original equation, everywhere you see an x, replace it with a 2. So I have 2 plus 4 over 2 minus 2. Does that equal 8 over 2 squared minus 2 times 2? Right, so this is 2 plus 4 over 2 minus 2 is 0. 8 over, this is 4 minus 4 is 0 again. What is true about division by 0? It's not possible. It's undefined, right? So this is not true. You can't divide by 0. So what I've written here actually makes no sense. So x equals 2 is not a solution. The only solution is x equals -2. So definitely mandatory that you go back and check, because you will often get an extraneous solution, a fake solution. All right, so that's it for the demo. You have some activities, and A, B, C, D. I want to make sure that you also, in the X even more practice, I really want you to do C and G. Okay. C and G. So make sure you do those before you leave, even if it means skipping some of the regular activities. Okay. I'll write it here.